Okay, let's pop back a bit and look at the glands of the endocrine system. And as I said, the textbook doesn't do a great job of this. Well, it does for free, but it doesn't do a great job. So we are just going to pop through the textbook and look at each of these glands, look at their location, the hormones that they release, and the actions of the hormone. So that's on the worksheet. Now, if we pop to the textbook, let's first look at the thyroid gland. The thyroid gland is at the base of the neck, and it has follicles. And the interesting thing about that is that it can actually store. So the thyroid gland is one of the few that can actually store the hormones. Now, it is releasing two hormones, and it is T4 and T3. Now, T4 is called thyroxine and T3 is triiodothyroxine. Now, the interesting thing about the iodo is there's iodine in it, and this is one of the few places in your body that uses iodine. That is actually why your salt, regular table salt, is iodinized, because we weren't getting enough iodine because we're not eating enough dirt. So that is the two hormones, and they are, the function here is they cross a membrane everywhere in the body and regulate gene receptor or gene expression. And here we go. The thyroid hormone increases the rate of metabolism in cells, allowing them to absorb more carbohydrates, use energy, and produce more heat. Okay, it can also increase the rate of the heartbeat, and that gives us sensitivity to our fight or flight hormones, such as epinephrine, also called adrenaline. Now, the thyroid actually has a second set of cells to it, the parafollicular cells, which are around, para meaning around, they're around the follicles. And the parafollicular cells release this hormone called calcitonin. Calcitonin is a hormone that will be triggered when there's too much calcium in the blood, and it will put it back into the bone. So I remember that as calcitonin, calcibonin. Put the calcium into the bone. So that is the function of the thyroid. Now, the interesting thing about the thyroid system is it has a very complicated system. It goes with the hypothalamus, which releases thyrotropin releasing hormone, which stimulates the thyroid stimulating hormone to be released, which acts on the thyroid, which produces T3 and T4, increases your metabolism, increases your growth, increases your effect. And once these are all doing well, it will feed back negatively on the negative feedback loop, and it will shut down the whole process. You do need to know what T3 and T4 does. You just need to be aware of thyrotropin releasing hormone and thyroid stimulating, so that when you hear them again in another course, you know that they existed. So that is the thyroid gland. We talked about calcitonin being released from the parafollicular cells. Another hormone that controls calcium is called the parathyroid hormone, which is released from the parathyroid gland, and it will have the opposite effect. So when the calcium is too low, parathyroid will act on your bones to release calcium from your bones and put it back into the blood. Okay, so if we look here, parathyroid has the effect of regulating calcium, and calcitonin is secreted in results of rising blood calcium. So if the blood's too high, it'll go into the bone. And if it is decreased, parathyroid hormone will be released from the parathyroid glands, and it will increase the calcium by taking it out of the bone. Okay, next is the pineal gland, and for the information on the pineal gland, we have to jump back to 9.2, and here is the pineal gland information. The pineal gland is a tiny gland located near the center of the brain. It releases the hormone melatonin, which controls the sleep-wake cycle, and it is stimulated by darkness. So that's why if you're not getting good sleep, you need to have darkness. This is also another reason why when it's dark outside when you get up and dark when you come back from work or school, you get sleepy because of the darkness. So if we look at this, the pineal gland is located in the central part of the brain. It releases the hormone melatonin, and the action is to control the sleep-wake cycle. Next gland is the pancreas. Good. When we look at the pancreas, we talk about it being an exocrine gland and an endocrine gland. The exocrine gland makes the digestive juices which dump into the digestive system. We're going to focus on the endocrine gland at this part. We'll talk about the digestive juices when we talk about digestion. So the pancreas has different lobes to it, different types to it. So it's got these acinar cells which go into ducts, which is the exocrine, and then it has these pancreatic islets. And the pancreatic islets have 4 different types of cells. We're only going to focus on 2 of the types of cells, the alpha cells and the beta cells. So the alpha cells release a hormone called glucagon, and glucagon it will increase when the level of glucose is gone. Glucagon is gone, and it will break down the stored glucose, which is stored in your liver as a form of glycogen. So we've got glucagon is the hormone, glycogen is the stored sugar, and glucose is just the sugar. So when glucagon is present, glucagon will break down glycogen into glucose, and that comes from the alpha cells. The second one you may have heard of comes from the beta cells. The beta cells releases something called insulin, and the function of insulin is to take the blood glucose out of the blood and put it into the liver and store it as glycogen. It will also store it as fat, and it'll store it in your skeletal muscles. Now, there are other types of cells, the delta and the gamma. We're not going to worry about them at this point, but I want you to be aware of them in case you do any further study of the pancreas. Okay, we're going to pop back to 9.6 for the adrenal glands. The adrenal glands are located on the top of the kidneys, and they have a bunch of layers, but I really only want you to focus on 2. The outer one is called the cortex, and the inner is called the medulla. The adrenal cortex has 3 zones. Don't worry about the zones. Just worry about what comes from the zones. So there are mineral corticoids, and mineral corticoids help balance salt minerals such as sodium using a hormone called aldosterone. So mineral corticoids, sodium, aldosterone. Then there's a glucocorticoid. Glucocorticoids help to release more glucose, and that is by releasing cortisol. And cortisol will increase the level of glucose and fatty acids in the blood. The third one that comes from the adrenal cortex are androgens. And androgens are the precursor for testosterone and estrogen. And androgens are available in both sexes. And sometimes this is why older women have beards, because as the estrogen decreases in the older women, the androgens will be created into testosterone, forming a little beard. And that is the cortex hormones. Notice that 2 of them have cortico in it, mineral corticoids and glucocorticoids. Now, there is the, again, a beautiful feedback loop because it goes back. The next we talked about was the inner part, and inner means medulla. So if we look at the medulla releases something called catecholamines, which are used to be called adrenaline, but adrenaline is now called epinephrine and norepinephrine. Okay? And these act on the nervous system and talk about fight or flight, which we mentioned in the nervous system earlier. Fight or flight. Good, and that's the sympathetic nervous system. So that is the adrenal medulla and the adrenal cortex. 3 come from the cortex, 1 from the medulla. Well, actually 2 from the medulla, the norepinephrine and epinephrine. Okay, we're popping around again. In order to address the ovaries and the testes, which are called gonads, we had to pop back to 9.2. So the gonads are the ovaries in females and the testes in male. The male hormone is testosterone and the female is estrogen and progesterone. And these are quite detailed. Again, we barely talk about it in the reproductive system, which is at the very end. The last gland I want to talk about, the thymus gland, and that is the one located at the base of the neck. Now, when we talk about immunity, we'll talk about T cells and B cells. And the T in T cells are that those cells went into the thymus for an education. I know, that's what they say. Okay, so that is the introduction to all your glands. I want to just finish off with the discussion of a negative feedback. A negative feedback loop is a way to control something by, if there is too much, you shut it down. If there's not enough, you turn it on again. And the good example they use in the textbook is thyroid hormones. So the thyroid hormone secretes T3 and T4. And those will go into the blood. If there's too many, it will act on the hypothalamus to say, stop releasing thyroid releasing hormone, which will stop acting on the pituitary, which will stop with the release of the thyroid hormones. So the whole idea is that the negative feedback will regulate or stop things. There is a positive feedback loop, and really there's only 2 spots where there's positive feedback in the body. One is blood clotting. Your reaction will go until your blood clots. And the second is prolactin, which helps with nursing. So when the nipples are stimulated by the suckling baby, it will send a message to the hypothalamus, to the pituitary, which then triggers the mammillary glands. So a positive feedback loop will turn things on, and a negative feedback loop controls it and shuts it off. When we look back to the endocrine note page, you're almost done now. But the other ones, I want you to extract your own information and look at how insulin and glucagon maintain the beautiful balance or homeostasis by looking at 2 videos. What does the pancreas do? And the control of blood glucose. And then in that one, please describe it. And if you go to your Blackboard page, as I said, the glucose insulin homeostasis is on the Blackboard page. So go to the Blackboard page, and here is the blood glucose homeostasis assignment. So I wanted you to watch those 2 videos and then summarize how the pancreas secretes insulin and glucagon and how that is a beautiful chart. You could make it in a flow chart if you want, but basically it's 6 marks in total. 2 for telling me what gets insulin going and its action, 2 to tell me the stimulation and action of glucagon, and then somehow show me how it is interacted. And that is due on the 6th because you guys have a bit of a holiday. Good. And that is the introduction for the endocrine system. A lot of memory work and big words, but you can do it.